radius r, b bar everywhere is out of the plane. I'll show at only one point. There's the thing. We have a small bead of mass 7 positive charge q is mounted on a fixed thin smooth horizontal plastic ring of radius capital R. Okay, this ring is fixed, it will not move. Magnetic field equal to switched on, where denotes time r distance e naught. Magnitude of normal reaction exerted by ring on the bead is q naught. Where is the bead? The bead, let it be like this. You know circular motion, mechanics, go back to some mechanics or laws of motion. Let's have, there's a bead. Diagram need not be given. You are supposed to imagine the situation. The magnetic field is switched on. So will there be any thing that will happen here? Okay, let's do one thing. At the location of there's a charge. This particular is having a charge Q. It's having a charge plus Q, that one. Will it move? Anything will happen to it. That's what we should do. We should look at the induced electric field idea, because B is varying. Where all in a numerical B varies, no? Bring the idea of induced electric field. So according to the formula, E bar dot dl is equal to S dB by dt, or S dB dt. E dl pi r square E naught by r. B as a function of time after differentiating will end up this one. So this will be, what is the dl? Dl is this one. Let me show it here. This is a dl. And this will be E bar. It should be tangential everywhere. No, so this should be how much? 2 pi r. I think there's a formula. What is this small r? Where r not equal to 0 is switched on, where t denote time, r distance from the z axis.
Have to integrate, sir.
No, I think I'm
taking small ring of thin.
Oh. R is the distance from z axis, no? In which plane it is lying? I think I didn't understood. The ring lies in xy plane. Z axis will come out of the plane, no? Oh, R is a radial distance from Z axis is telling. So R is a, I think I'll do one thing. R is a radial distance. So we do have, this is not something like smaller, I'll measure from radius. So we'll try to have small diagram. Okay, I'll bring the concept involved. We'll have small first. It is like this. B bar is out of the plane everywhere. So let me first calculate the flux linking this one. So what is the flux linking this? D phi is equal to, B bar is variable, no? B is not uniform everywhere. It is varying with radial distance. So flux linking this, and let this be R. Okay, d phi is equal to B into dA. So this will be E naught T by r 2 pi r dr. 2 pi E naught T so flux linking from 0 to phi 0 to r. Flux linking the total ring. This actually ringer will be 2 pi E naught T r. Now I'll come for this one. E bar dot dl is equal to d phi by dt. So this will become E into, we'll get expression for E. So E into 2 pi r d phi by dt. So I got the induced electric field is just equal to E naught. What did they see? Induced electric field on the ring. Okay, that E is what I can show it here. Because of this E, there's a positive charge, so it will experience a force. Okay, let's calculate that force, M into A. So this will be QE. So then QE naught is equal to M dV by dt. dV is equal to QE naught M dt. Or why all this? It's a unit constant acceleration is how much? Tangential acceleration. Better let me write. Again, you think that straight line motion, it is going to move on the ring. So this A tangential should be equal to Q naught E by M. So what is the speed? Tangential speed should be A tangential into this one. So this will be Q E naught T by M. Okay, this is a tangential speed of the particle. So what is VT you should call? Okay, what is the question is asking? Just normal reaction. Now tell me like because of tangential velocity at any instant of time. Okay, shall we do one thing? We'll take it any instant of time. Some after some time, no? We will see like this. Now what are the various forces that we can show it on it? It will have tangential velocity. Then even magnetic force also, B bar QVB. Now, how the normal reaction should act? Any direction or any specific direction? The normal reaction should act in this direction. Oh. Fine. This is I'm taking like this. Normal reaction should be in that direction. So what is actually, if you're still not getting idea, so this is the actually the bead, the particular bead, no, or the ring will have a position like this. If you are able to imagine, well and off, or all else, unless to the diagram, it will have tangential velocity Vt, magnetic force. So therefore the normal reaction by the ring on the particle will be in this direction. There the diagram, I'm just showing this one. So if you expand, no, this will be the situation, and this will be the direction of E bar. So therefore, what is the equation? We can write it here now. The normal reaction, looking at this, the normal reaction should be N minus QVB equal to N minus okay, expression for VT, you know it, substitute that. Now what is B again? Again, you have to substitute B, the same original formula. Okay, let me do all the calculation part. So this will be N, VT is how much? Q E naught MT. B is how much? B is E naught T by capital R. Okay, I have to substitute VT value, no? Tangential velocity Q E naught T M. Anybody? N
2q square E naught square T square by M.
or 2 times of that it will come. Huh?
Yes, sir, 2 times of.
Magnetic force, correct? Huh? Did I assume properly?
Yes, sir.
B
Sir,
bar
correct.
velocity. Yeah, fine. N equal to, we are getting 2 times. Huh? 2m. M will not be there. Yeah, okay, fine. 2 some interlinking of ideas. Huh? Induce electric field, then interlinking of ideas.